Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alhamdulillah. I already promised that I will show you how we do assemble in our project for this glass suction cup mount holder. So in this video session, I will show you how we do assembly in SolidWorks. So how we put the component into the right position, we assemble it, and until we finish the whole thing, as shown in this image. Okay, the whole products here. If you look on this image, the glass suction cup mount holder, we have a lot of components here. We have about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 16, 17, I think it's about around 20 components. Okay, we have a lot of components as well. I would like to suggest to you that we divide this component into two two groups. The first group should be our bottom assembly group, and the next group will be our top assembly group. Okay, if I show you this image, so this is a component for bottom assembly group. Okay, the bottom assembly group will be this group. So this is our bottom part of the component. Okay, the bottom, our bottom assembly. Okay, our bottom assembly. So we have a suction cup, we have a main support here, we have a casing, we have a knob here, and we have our gear here and a screw there. Then inside we have a spring, and also we have a pin. We have a pin there. So inshallah, in this video I will show you the first our first video session will be this bottom assembly. Inshallah, in the next video session I will show you the other assembly, which the top part assembly. Okay, so in SolidWorks, when you want to do assembly, when you open a new file, make sure that you select assembly, then you click OK. And now we are in assembly mode. So initially we have a setting here where we can put our component here, we can insert our component. So it's better practice to, in this group of assembly, so what I will do, I select this main component here. Our base support here will be our vertical support here will be our base component. So this component, since this component will not be moved in our assembly, so we consider this component will be in frozen mode. It will be static. Okay, so the first thing what we should do in SolidWorks, we insert our main component first. So the name of the part, make sure that you know all your parts name. Okay, the part name in my case is bottom support. Okay, firstly, your main component here, okay, your base component here, so make sure that you don't click in the viewports here. What you should do, you just simply click OK, so that you will put into the origin point. Okay, in this assembly setting, if you look on the list here, our bottom support component here is there, and also in bracket, the bracket F means that it's in frozen mode. Frozen mode, it means that this component we can't move it. Okay, we can't move it. Okay, the next thing, you insert all the other component, like as shown in this image. We have one here. We have here we have two components, suction cup and knee. So we have about around 8 components here. We insert the components. Okay, we have this another, we have casing here, and okay, I made it short in this video, so I already inserted all the component here. We have a suction cup, we have vertical key, we have a pin, we have a control knob here, tightener. So we have a gear, we have a screw, and we have a spring, conic spring. Okay, firstly, since our main support here is static, So what I should do first is I should put this this vertical key into this session cup. Okay, so we have a setting here, we have a tab here. When you click at here, we have made. When you click at made, so you will open up a made setting here. Under made selection here, you can use since I want to move this vertical key directly into this session cup, so our made selection, so I will use firstly I will use this vertical cylindrical surface here, and this cylindrical surface of this session cup. So automatically will set into the, also will put you into concentric mode. Concentric means that this both of these components share the same axis, okay, in center position. Okay, in center position. So that's our first made setting. Okay, then we click OK. Then we click OK. Our second made setting is that we should put this vertical key put into the right position there, so it will nicely fit, nicely fitted into this session cup. So what I will do, our next made selection, I will select these edges of this vertical key, and the edges of the session cup will be inside edges there. So if it is difficult for you to select, so what we should do, we simply right click our mouse button, right click mouse, we can use select other, so we can select appropriate edges. So the edges will be there. So if I select the edges, so then the vertical key is nicely fitted. Okay, nicely fitted. Then we click OK to set our made. So you can check, you can even check by select, we have a button here, session view. If you click at session view, you can have the option to use front or top or right plane. In this case I use let's try for front plane. We can drag our front plane to check the assemble of those two components now. So our vertical key, if you look, our vertical key and our session cup is nicely in right position. Okay, it's nice. So we off, that is off here. So go back to normal view. So next thing, what we should do, so we should move these two components to the bottom of this base support here. Okay, we go to made, same approach. We use the cylindrical surface of this session cup and this cylindrical surface of this vertical key, so it will be set into concentric. Then we click OK. Okay, the next setting is that we should, if you look, since our vertical our glass suction cup here is on top of this vertical key, we should make it to snap it at the bottom of this vertical key. So our next setting will be the top surface of our session cup, and the bottom surface of our base support. So it should be coincident. Okay, now they are in right position. Okay, so we have already 3 component assembled here. So the next step will be we got to move this tightening knob here, the tightener here, into the right position here. So what I will do, I will select the inside cylindrical surface of this knob and this cylindrical surface here, make sure that it's in concentric. Then we click OK. Since this component, this tightening knob in concentric, we can drag it, we can simply move it. Okay, it's already been set into concentric. Okay, what we should do next is that if you look at the bottom of this tightener knob here, so we have a bottom flat surface here. We select the bottom surface there, and if you look at this base support here, this dome surface here, we have at the top portion here, we have flat surface there. so both of the surface will be in coincident. Okay, so the knob is in the coincide with the flat surface of this dome. Okay, so now we can move the knob. We can rotate the knob, but we cannot drag. We can't drag it upward since it's been set into the two mate setting. So if you look, we have a, if we zoom closely, we have a slot here. We have a circular slot at this dome shape, so we need to adjust our knob here so that it will be put in the position where it will be around that circular slot. Okay, let's adjust our knob slightly so that this, we have a groove here. Okay, the groove of this knob in slightly in right position, same alignment with the axis of this hole here. Okay, alright, what we should do next is that these pins here should be moved into this hole. So we use the same approach here. So since if you look, zoom it closely here, our pin part here, I already made the pin part, the pin file. I already add an axis here, an axis from this bottom surface to the other surface there. Okay, we have I already added extra axis there, center line. So I can use this. Make sure that your parts, like certain parts, you need to put in your SolidWorks part file extra axis there. You have to put then before you save it. So in this pin component here, I already put an axis there. So I can use this axis of this pin, the axis of this pin, and this whole surface. So SolidWorks will put it into coincident position. So it means that in the both share the same axis. Okay, they share the same axis. Then we click OK. Okay, what we should do next is that I can select the surface of this. Since I don't want to simply drag the pin there, I can use another mate selection. I select this flat surface of this pin, and surface of this cylinder, and it will set into tangent. Okay, tangent, it means that this surface, since the surface of this pin is flat and the surface of the cylinder is curvature, so it's in tangent position. So in tangent position, so our pin will be nicely fit into the okay, let me undo it again. See, it should not be coincident. Let me undo it again. Something wrong with our mate selection. Okay, undo until we back into the okay, let me show you again. I made some certain undos. Okay, at the position where this our pin here, the pin here, we do it again for mate setting. We select the axis of this pin. Okay, the axis of this pin and the cylindrical surface there. Okay, the whole surface there. It should not be in coincident. It should be in a concentric. Okay, it should be in concentric. Concentric means that you will share the same axis there. Okay, the hole and the pin will be at the same center point there. Okay, the same center point. Okay, then we click OK. Okay, our another mate setting is that we make sure that our flat surface here, flat surface of this pin and this cylindrical surface should be in tangent. Tangent means that this flat surface and this curvature surface of the cylinder in tangent mode. So you will be in the correct alignment. Okay, then I click OK. So our pin will be nicely fit into the hold of the vertical key. Okay, hold over the vertical key. So then we click OK. Okay, then we click OK. So we have done this part of this assembly. Okay, the next thing here, we have spring here. When we have a casing here, spring and casing, also like the pin. Okay, I just would like to remind you that in my spring component, I add some axis there. Make sure that in your solid part file you have axis there. You add extra axis there from the bottom plane of the spring and the top plane of the spring. We add either front view or right view. We add a center line there for axis. Then you save your part file. So that we can use this axis as our reference for our mate selection, mate setting in our assembly file. So the next thing to do is in our mates here, the mate setting, we select the center line. Okay, this axis of the spring and the cylindrical surface of this casing. You must make sure that it's in concentric. Okay, not coincident. Concentric. Concentric means that is in the right center point. Okay, right center point. Then we click OK. Then we click OK. Next, we got to move this spring directly touching the bottom surface, inside bottom surface of this casing. So I can use, since we have the axis here, I can use this end point of this axis and if I drag it, this view, and the bottom surface, this bottom surface there, so it means that spring will be touching, that end point will be touching to the surface. So make sure that in coincident, then we click OK. So then the spring will be nicely fitted and touch into that bottom surface of the casing. Okay, then we click OK to set it. So just for checking, then let we do some sectioning here, section view, just to check whether our spring let me click OK. Okay, let's try another view, another section view. Not this by using, instead of using front view, use right plane. Let me drag. Make sure you reverse direction. The purpose of me doing this is to check, to make sure that my spring is in right position by checking, by doing this section view here. So it seems like our spring is yeah, I think our spring is in correct position. Okay, then okay, next thing, we got to move this both component here. We have spring inside here. We got to yes, we got to move this casing into this base support here. So we go to mid. Okay, same approach. We select the cylindrical surface here, vertical cylindrical surface there, and our cylindrical surface here. Then make sure that is in concentric. Okay, then we click OK. Right, then since the orientation, I think I already made this assembly. The orientation of this, if you have this bottom support here, we have circular slot, and our casing here is the same orientation there. Okay, the bottom surface of this casing will be directly nicely fit inside the circular slot, so we can simply use. They are both in same orientation, so what I should do, I just simply select this bottom face here and this surface, so it will be nicely fit into this base support. Okay, so we have our almost finished assembly of our bottom assembly. Okay, what's left is we have these two components. Okay, these two components we have gear here. Okay, we select the cylindrical surface of the gear and this cylindrical surface of this. Carefully select the cylindrical surface of this casing. Make sure it is in concentric here. Click OK. Then the next one will be, we also must make sure that we have 4 key here. Make sure that the orientation of the key is right orientation with 4 holes here. We have 4 holes here. So since this file is in the right orientation, so I can simply select the bottom surface here and the top surface here, so it will be coincident mode. Okay, then we click OK. Okay, the last component should be our screw. Okay, the screw, what we should do. Okay, for the screw, okay, what we should do for the screw is that, let me zoom in. We carefully select the cylindrical surface of the screw and the pen and this cylindrical surface, so they are both measured in concentric. So since if you look, the direction of the screw is in the wrong direction, so we have to put the direction of the screw towards this component. So we have an option made alignment here. So this also already been set aligned, so we need to make sure that it's anti-aligned, so the screw direction will be in the right direction. Then we click OK. So then the next setting will be this bottom surface, since we have flat surface here of the screw and this surface, so it will be coincident. Okay, coincide with the surface. Okay, then we click OK. Okay, I think let's check. Okay, let's check our file, our assembly. So all the components already been assembled. So just for checking, if we click OK, then we go to section view. Let's go to instead of using right plane, we use front plate. Then we make a check make sure that reverse direction, just for checking. Right, the first thing what we should check is we look on our screw component here. If I drag it a little bit here, okay, let me do it again. Okay, click OK. Okay, since if you look, all the component I think is in the correct position, but except our, if you look, our spring. Okay, since we have our vertical column here of our base support, we have a kind of rib, so this rib have been cut through, so they form kind of plane here, so the spring is intersect with the screw. So what we need to do, so we need to do some modification of our screw component. Okay, our conic, not our screw, I mean our spring component here, since the rib intersect with the spring, not screw, sorry, it's not the screw, and with the spring. Also, if you look inside here, if you look, our screw component here also intersect with the surface of this vertical support cylinder here. So it means that our screw is not on the same alignments. If you look carefully at the top part of the screw alignment here is in at angle here, so we need to do some adjustment on the screw set. It would be so that our, what we need to do right now, so first we have also another thing I got to show you is that the bore of this vertical gear is not at the diameter is, I think, is totally wrong, since is the diameter is small, quite small, so the screw, the thread portion of the screw will cut out this bore. So what we need to do, we need to increase a little bit the diameter of this okay, first thing what I want to show you is we adjust the gear component here, the vertical gear here, okay, the vertical gear here, so that we adjust the dimension, the diameter of this vertical gear. So what we should do, I would like to show that if I zoom out a little bit. Okay, then if I off this, if we select this component, if you select this vertical gear, if you double click on it, so we have a parameter, we could adjust it. Okay, you can simply adjust, if you look on the diameter there. Okay, if you look, we have a diameter 7 there. Okay, diameter 7. So what we need to just not the diameter 7, the inner portion of the gear. If I click on this surface, if I double click, we have a okay, if we click on the surface, we have some adjustment that we could make for this vertical gear. Okay, if you look on the setting, we have a diameter 3 here. It means that the bore size of this vertical gear is the 3 is too small, so we need to increase it a little bit so that the screw thread will not cut out the inner surface of the bore. Okay, so we need to, if I click on the dimension, if I double click on it, so we could adjust it, let's put it something 3.25. we increase a little bit the diameter. Okay, then we click OK, then we rebuild it. Okay, then we rebuild. So if we do some sectioning again, okay, then if we go to section view, sorry for having a very old laptop here, so it takes a lot of CPU and memory. So since if you look at the diameter of 3.25, since it's still small, so we need to do another, if we double click, let's go for, instead of 3.25, let's go for 3.5. Click OK and rebuild. Okay, if you look, 3.5 bore seems to be okay, so the screw thread will not cut out this inner surface of this bore of this vertical gear component. Okay, so the purpose of me showing you here, you can do some alteration, modification of your component. Since you have modified this vertical gear, you increase the diameter here from, instead of 3 into 3.5 millimeters, so automatically your component file here of this vertical gear will be adjusted. It will be adjusted, it will be updated for your component files here, your part files. Okay, so we already adjust. So another thing to do is, if you look, the screw thread here at a little bit not in the right orientation. So if you look on the screw thread of this screw, is intersect with this rib surface. So okay, if we look carefully, if we zoom in, this is a section view. If we look on our screw component, the screw thread here and the rib, the thread is not in the right orientation. It can be a little bit intersection, it cut out here. Okay, it's already, we have a intersect here. So what we need to do, so we must make sure that in the, because since if you look on the screw in the screw key slot here, so we need to set mate selection to make sure that this face of the screw in parallel with this plane, this surface. So what I will do is that we go to main and we select this surface of the screw. Okay, and we need some vertical surface. Maybe this, yes, this the surface there. Okay, make sure that in we just ignore this warning, we just click it to parallel, so it means that the screw is in the right position, so it will not cut out the portion of the rib. If we zoom closely, since this view is section view, if you look, the thread is okay, the external thread here will is in line with the internal thread of the component of this vertical support of this column. Okay, then we click OK, we set that, let me off. Since this view have been shown, I already hide the component, so let me the component, the conic here, I can make it show instead of hide, and the component here show. Okay, so since in this video I skip it how I hide the component, so I show it again, so because it's easy for us to adjust the screw position and the inner thread of the vertical section. What I did just now is because since this portion we don't need it in our setting for our mate, so when you select this component and we have option to hide it, okay, like this casing, we can hide it. So maybe we could concentrate, for previous case, to adjust the thread, we should concentrate on the vertical this screw and this vertical column here. So that's what I did just now. So I unhide, show it, okay, select the component and show it. So we have our component there. So our screw have been adjusted. Okay, the thing that is not adjusted yet, and is if I do a section cut again, like I mentioned just now, so our conic spring is cutting our rib component. So you can either adjust it in this assembly file, or you can open your part file of your conic spring here, your spring component here. You open the file again and you adjust the diameter of the spring, so that it will not cut out this rib component. Okay, so what I will do, I will open the spring that I used in this assembly. Okay, so, okay, this is our spring. Since in this assembly the spring will cut out certain portion of the rib, so we need to increase a little bit our spring diameter there. Okay, we go to our spring file. So in this spring file, if I look on the setting of my helix here, if I open the helix setting there, okay, this is our helix for the spring file. This spring, I use variable pitch. Okay, variable pitch. Since the variable diameter at the bottom we have bigger diameter, and the top part we have smaller diameter. If you look only by using variable pitch, I have settings here. So if you look on this portion, the second portion, is I should little bit increase. Let me increase if we have diameter there. Instead of put it 11, let's try we put it around. Let's go for 13 just in case, and let's put this on 14. Okay, and this one for 13, 14. This one should be, let's do it for 15, and here we increase it. Let's try this one for 17, and the bottom, the last one diameter is okay. Okay, let's click OK. Then okay, we rebuild it. Okay, when we do some adjustment in this part file, when you go to assembly, so in the assembly mode, it will automatically pop up this some models contained within the MZF change. So we click yes, we rebuild it. Hold on. Okay, we rebuild it. So if if you look still in our assembly here, still the diameter, the upper portion of the diameter, still not that. We still need to increase it a little bit, so that it will not cut this rib portion here. Okay, so I need to make some more adjustment on the original file here. So we go to helix. Okay, that will increase it. This one will be 16. No, not the height. Let me undo again. Okay, what I should change is the diameter. Okay, initially we have 11 here. Okay, I should put it here around 17. The diameter around 18. The bottom diameter should be around 19. It's around 20. This this example out. Okay, let's go for 16. This one I change back this one to 17. 17. Okay, let's go for 18. 19. And let's do some we already made some adjustment here, so let's go to our example. We click yes. It looks like our spring is too big. So the spring before it cut out the 3, but now it's too big, it cut out the portion of this casing, so we need to reduce it a little bit more. So let me, okay, after I've done some adjustment on the spring with certain dimension here, I already adjust diameter here is 14, and the second diameter 15, and the third diameter 17, and diameter 17 and 17 here, since this spring is a kind of conic spring. Okay, so after we have done some adjustment of the spring, so it seems like in our assembly settings here, if we make some changes, so it looks like the spring is already adjusted, the dimension of the spring, so I think the spring has already been corrected, so it will not cut out the portion in either. I still need to do some another adjustment here, since this spring's diameter is too big, so it cut out the portion of the casing here. Let me check again. And let's decrease a little bit on this one to be 16 instead of 17. Okay, 16. Then we click OK. Then in our assembly we click yes. It will be rebuilt. So it looks like the okay, we have already adjust our spring dimension, so it will nicely fit in this inside this casing. It will not cut out any portion of the casing inside. Okay, I think okay, we already did some adjustment on our bottom assembly here, so we off this section. So I think we have done for our bottom assembly part. Okay, Alhamdulillah, inshallah in the next video session I will show you how we do assembly on the top assembly, on how we do some adjustment that I showed you just now. Okay, thank you very much for watching this video. Inshallah I will be seeing you in the next video session. Assalamualaikum warahmatullahi ta'ala wabarakatuh.